Mars is easy to recognize from a distance, not because it shines brighter than the others, but because it looks wounded, stained red, as if the planet itself has been left out in the cold and slowly oxidized into rust. For centuries, we called it a symbol, a god of war, an omen, a promise. But today, Mars has become something stranger. It has become a place with footage, with sound, with hours that can be counted. A world that was once only a point of light is now a landscape we've stared at long enough to feel we almost know it. And that familiarity is the paradox. Because Mars still isn't ours. It is still millions of kilometers away, a desert locked in deep freeze, wrapped in air so thin it barely deserves the name. And yet through the senses of our machines, we've begun to experience it like a memory. Mars is the fourth planet from the Sun, and despite its barren face, it carries companions, two small, peculiar moons, Phobos and Deimos. They look less like noble satellites, and more like captured debris, dark, misshapen fragments that never had the dignity of becoming round. Everything about Mars is slightly off, like a familiar song played in the wrong key. The days are close to ours, but not quite. The gravity is gentler, the air is quieter, and the sunsets against all instinct can burn blue. Not the warm orange of Earth, but a cold, inverted twilight created by dust so fine it hangs in the sky like invisible ash scattering light in a way our eyes weren't evolved to expect. And yet after Earth, Mars is the world we've documented the most. Not with poetry, with hardware, with orbiters that map from above, with landers that feel the ground, with rovers that crawl across stone that hasn't been touched by anything alive for unimaginable spans of time. Mars has been the target of countless missions because it sits at the edge of a question that refuses to die. Was it ever different? Was this silent planet once a place where water moved, where chemistry had time to climb toward life? If the universe can make biology anywhere, surely it would have tried. Here on a world that once had rivers, lakes, and a thicker atmosphere before time peeled it away. That question is what brought one of NASA's most ambitious explorers to the edge of the unknown. On July 30th, 2020, a rocket rose from Cape Canaveral carrying Perseverance, an entire moving laboratory wrapped in metal and patience. It wasn't alone. Tucked beside it was a small experimental helicopter named Ingenuity, a fragile idea riding shotgun to a far harsher reality. The plan was simple in concept and brutal in execution. Cross deep space, arrive at Mars, and land safely. 6.5 months later, on February 18th, 2021, Perseverance reached the Red Planet and entered the most dangerous part of the journey, what engineers call the 7 minutes of terror. 7 minutes doesn't sound like much until you understand what it contains. In those minutes, the rover had to slam into Mars's thin atmosphere at interplanetary speed shed. A heat shield deploy the largest parachute ever used on Mars, and slow itself enough for a sky crane to hover like a mechanical insect in a dust. Storm lowering Perseverance by cables onto the ground. No second chances, no joystick, no human hands, just physics code and an ancient world waiting below. And then it worked. Perseverance touched down in Jezero Crater, a scar in the planet's surface about 28 miles wide, chosen not for beauty but for evidence. Long ago, Jezero was a lake. Water once flowed into it, at least twice, carving channels, building a river delta, laying down sediments like pages in a book. From orbit, instruments had already seen minerals altered by water, chemical fingerprints, that whisper of a time when Mars was not only wet, but potentially habitable. This crater wasn't a random destination. It was a bet on the past. Because Perseverance's mission is not simply to roam. It is to search for signs of ancient life. Not fossils you can hold in your hand, but subtle traces, patterns in rock structures, in minerals, chemical imbalances that shouldn't exist unless something once fed on energy in the dark. The rover drills, collects, and seals samples into small tubes, storing them like time capsules for a future mission that may bring them back to Earth, where our best laboratories can interrogate them with instruments far more powerful than anything we can fit on a rover. But to reach that future, we first had to learn how to be present on Mars, how to experience a planet that doesn't want us. And that's what makes this era unprecedented. Mars is no longer only data and distance, it's wind captured by a microphone, dust devils filmed crossing a crater floor. A sunset turning the sky the wrong color. Night falling fast, temperatures collapsing, machines huddling against the cold to keep their own minds from freezing. Through perseverance, we are beginning to understand what day and night truly feel like on another world. Not as a fantasy, as a record. Type continue to write chapter 2. To understand what a day on Mars really is, you have to abandon the comfortable assumptions Earth has trained into you. On Earth, air is a thick ocean. You live at the bottom of dense enough to carry sound with clarity, to soften temperature swings, to turn sunlight into warm color at the horizon. On Mars, the atmosphere is a ghost. It's mostly carbon dioxide spread so thin that wind can move dust, but struggles to carry a voice. The pressure is a small fraction of what we breathe here. And because there's so little air to hold heat, the planet bleeds warmth into space the moment the sun slips away. Day and night on Mars aren't gentle transitions. They're sharp changes in survival conditions. Still, Mars rotates with a familiar rhythm. A Martian day, a sol, is only a little longer than ours, about 24.5 hours. That small difference is enough to make time feel subtly wrong, as if the planet is always slightly out of sync with the life you know. And the gravity, about a third of Earth's, makes everything lighter. Not in a joyful way, but in a way that reveals how much of what we call normal is just physics, acting consistently. If you stood on Mars, you would feel the same body but less anchored. A softer pull from below and above you, a sky that is not blue but dusty, often tinted with a pale butterscotch hue, the color of suspended rust. Those two small moons add to the unease. Phobos and Deimos look like captured asteroids, because that might be what they are. Irregular rocks trapped by Mars's gravity long ago. Phobos in particular is unnervingly close. It orbits so fast that it rises and sets in a matter of hours, a jagged shadow racing across a thin sky. It doesn't belong to the slow dignity of our moon. It feels temporary. And it is. Phobos is gradually spiraling inward, destined over millions of years to break apart or crash into Mars. Even the sky carries a countdown. We've learned these things because Mars has been watched, measured, mapped, and revisited more than any world beyond Earth. Orbiters like the Mars Reconnaissance Orbiter have scanned its surface in exquisite detail, reading ancient layers like geology turned into handwriting. Landers have tasted the soil, sniffed the air, tracked the weather. Rovers have served as field geologists, curiosity, perseverance, moving slowly through landscapes that look like deserts but are really archives. Every wheel track is a line drawn across deep time. That's why Jezero matters. A crater can be an impact wound, or a bowl that once held a lake. Jezero's shape and mineral signatures suggest the second. The fossilized river delta preserved along its rim is the kind of structure water builds patiently, grain by grain, year after year. And water changes everything. It dissolves, transports, concentrates, it creates niches. It allows chemistry to repeat experiments until something complex appears. If Mars ever hosted microbial life, it would have lived in places like this, where water met rock, where sediments settled, where energy gradients existed long enough to be exploited. Perseverance arrived with that context embedded in its design. It is a rover, yes, but also a sampling machine, a chemistry lab, a camera crew, and something we've never truly had on another planet before. A way to make Mars feel immediate. High-resolution panoramas aren't just pretty images. They are terrain models for navigation, geological clues for scientists, and psychological bridges for us. Video 2, motion captured in an alien environment, carries a different weight than still photography. It turns Mars from a postcard into a place where events happen in time. And then there is sound. On Earth, sound is almost automatic. Air molecules pressed into waves by vibration, arriving at your ears as a continuous stream of information. On Mars, sound is a struggle. With so few molecules to push against each other, audio becomes quieter, thinner, oddly muffled, especially in lower frequencies. Even a simple gust of wind becomes a rare physical message from a world that rarely touches you directly. And yet, Perseverance carries a microphone. Not a novelty, but an instrument that turns an abstract planet into a sensory environment. The first time we truly heard Mars, it wasn't a dramatic roar or a cinematic scream. It was subtler. Wind, crackle, the sound of a thin atmosphere brushing against metal. All of this is context for what comes next. The moments where Mars stops being a concept and becomes an experience. The filmed dust devils crossing Jezero, the blue sunset bleeding across a horizon that has never seen an ocean, the long time-lapse of a sol passing like a quiet tide of shadow, and the operational reality behind it all. The way exploration is shaped by sunlight, power budgets, cold nights, and even the alignment of planets. Mars doesn't just test our curiosity, it tests our ability to exist even remotely in a place built to erase us. Type continue to write chapter 3. The romance of Mars is easy to sell: red horizons, lonely mountains, the dream of another shore. But the reality of exploring it is a chain of constraints so unforgiving that every beautiful moment is purchased with discipline. On Mars, nothing is free. Not movement, not warmth, not a single second of communication. Even daylight is rationed because sunlight is not just illumination, it is energy, time, and safety. Perseverance is designed to work like a careful creature. Most of its tasks happen during the day when the world is visible enough for autonomous navigation, and when power can be managed without draining reserves into desperation. The rover's systems must constantly balance exploration against survival, drive, drill, image, analyze, but also stay warm. Keep electronics within operating limits. Protect delicate instruments from cold that can turn precision into vexure. When night arrives on Mars, temperatures can plunge so low that the planet feels less like a desert and more like a deep space environment wearing a thin disguise. A machine left unheated would stiffen its batteries, weaken its circuits, pushed beyond tolerance. So, the rover becomes cautious in the dark, conserving heating, waiting. Because on Mars, the simplest enemy is the loss of warmth. And yet the story of a Martian day is not only about the sun rising and setting. It's about the atmosphere coming alive in ways that look familiar but behave differently. One of the most striking examples arrived on July 20th, 2021, when Perseverance recorded dust devils swirling across Jezero Crater. On Earth, we imagine tornadoes as monsters born from violent storms, but Martian dust devils are often born from something quieter, uneven heating. The ground warms in patches under sunlight, warm air rises, cooler air rushes in to replace it, and a spinning column forms an invisible vortex, made visible only because it lifts dust into the air like smoke. In Perseverance's footage, they appear like living brushstrokes, moving across a dead canvas, transient and elegant, reminding us that even a thin atmosphere can dance. The video was enhanced to make details easier to see, contrast, sharpened colors, adjusted not to invent Mars but to reveal it. Because a camera does not see like an eye, it records raw data. We translate that data into something human perception can grasp, and that translation itself is part of the paradox. Mars is real, but we always experience it through layers, through sensors, through algorithms, through transmissions crossing millions of kilometers. The planet arrives to us not as direct sensation, but as reconstructed truth. Then, another barrier fell. Sound. The first time Mars truly reached us through audio, it felt almost inappropriate, as if we'd listened in on a world that never agreed to be heard. The microphone captured wind and subtle crackles, a muffled, distant presence. And the physics behind it is almost poetic. With fewer molecules in the air, the medium of sound becomes sparse, so waves lose energy and certain frequencies travel differently. It's not that Mars is silent, it's that Mars speaks in a thinner language. A language that our ears, built for an atmosphere far denser, weren't designed to decode. The sensory story continued. On November 9, 2021, Perseverance recorded a Martian sunset. On Earth, sunsets are warm because our atmosphere scatters blue light away, leaving oranges and reds to dominate the horizon. On Mars, dust rewrites the rules. Fine particles scatter light in a way that allows blue wavelengths to push through near the sun, creating a sunset that can turn strangely bluish, a cold halo at the edge of day. It's one of those moments that makes you feel the alienness of a planet in your bones. The same star, the same physics, but a different atmosphere, writing a different sky. And sometimes the greatest obstacle isn't the environment at all, it's the geometry of space. On November 8, 2023, Curiosity captured time-lapse sequences showing about 12 hours of a Martian day, images taken just before a phenomenon called solar conjunction. For a brief period, the sun lines up between Earth and Mars. The distance is still there, but now the line of communication passes close enough to the sun that solar plasma can disrupt radio signals. So, NASA pauses command transmissions. Not because the rovers stop existing, but because the universe itself becomes interference. The star that gives light becomes static. During conjunction, the rovers continue in a kind of solitude, sending automatic reports, following pre-planned activities, surviving on their own. It is a reminder of how exploration really works at these distances. You don't drive a rover like a remote control car. You choreograph it. You teach it to decide. You let it live by scripts written days earlier, and you wait for the delayed echo of its actions to arrive back on Earth. Mars is close enough to tempt us with intimacy, but far enough to punish every assumption of control. That tension shapes everything. Daylight is a window, night is a test. Dust is both a spectacle and a threat, and even the sun can become a barrier. And still, through all of it, perseverance and curiosity keep recording, because every image and every sound is more than content. It is evidence that we can extend our senses beyond our world and survive the delay. If you strip away the cameras, the headlines, the romance of a rover crawling across a red horizon, what remains is something more serious, a forensic investigation into a planet's vanished habitability. Mars is not just a destination. It's a crime scene billions of years old, and the clues are subtle, frozen into minerals, buried in sediments scattered across the floor of an ancient lake that no longer exists. Jezero Crater is where Perseverance turns that investigation into a physical act. The crater's story is written in shapes you can see from orbit channels that converge a delta, fanning out like a handprint pressed into stone. Water long gone, left behind architecture. But the deeper evidence is chemical. Minerals altered by water preserve a record of reactions that only happen when rock and liquid meet for long enough. It is the kind of evidence that suggests not just moisture, but a persistent environment. One that could have held stable conditions, gradients of energy, and the slow repetition life requires. And life, if it ever existed on Mars, would not announce itself with bones or forests. It would hide in faint patterns, organic molecules trapped in rock pores, isotopic ratios, shifted by metabolism textures in sediments that suggest microbial mats. The problem is not that such evidence is impossible. The problem is that time is ruthless. Radiation breaks down organics. Oxidizing chemistry erases delicate signatures. Wind grinds surfaces into dust. Mars has spent eons becoming sterile, and whatever it once held has been fighting for survival in the archive ever since. That's why Perseverance does something more consequential than filming sunsets. It collects samples, not scoops of curiosity, but carefully chosen pieces of the planet's history cores, drilled from rock, sealed inside tubes stored like fragments of another era. Each tube is small, almost absurdly so compared to the scale of a planet. But inside those cylinders could be the most valuable material ever brought from beyond Earth orbit, a direct piece of Mars that can be studied with the full arsenal of human science. On the surface, this looks like patient geology, but underneath, it's a bet against the limits of robotic science. Because there are things you simply can't do on Mars with a rover. You can't bring a synchrotron. You can't run every mass spectrometry technique at once. You can't iterate endlessly with new hypotheses as soon as a surprising result appears. Our best laboratories are heavy, delicate, and hungry for power. So Perseverance's sample cache is an act of deferred understanding we will learn later, with better tools if we can bring these sealed fragments home. And while that long-term future waits, Mars keeps offering moments that feel like immediate connection. One of the most haunting is what happens at night. Just days after landing on February 20th, 2021, Perseverance assembled a panoramic view from images taken by its navigation cameras. 6 separate photos stitched into a single wide portrait of the alien ground around it. A panorama is not just a pretty sweep of terrain, it's situational awareness. It's a map of hazards, a record of textures, a way for scientists to read the landscape the way a geologist reads a cliff face. In that early panorama, you can almost feel the newness of the rover's presence, a machine freshly arrived, turning its gaze across a world that has never cared. Then on January 12, 2022, Perseverance pointed its Mastcam Z toward the sky and recorded Phobos during the night. It wasn't simply astronomy for the sake of wonder. It was measurement. Observing Phobos's passage helps scientists estimate how much dust is in the atmosphere after dark, then compare it with daytime conditions. Mars's air may be thin, but it's active, and dust is its bloodstream. Dust changes the temperature profile, influences weather, affects how sunlight warms the ground, and even shapes what our solar panels and instruments can do. Studying dust at different times of day is part of understanding the living behavior of a planet that otherwise looks inert. This is the strange heart of modern exploration. The same footage that thrills us is also calibration. The same images that inspire awe are also data points in atmospheric models. The same sound that feels like intimacy is also evidence about acoustic propagation in low-pressure air. Our emotional experience of Mars and our scientific understanding of it are not separate, they are entangled because both are built from the same fragile stream of signals traveling across space. And beyond the beauty and the measurements, the unknown keeps widening. Mars still refuses to give us a simple answer about its past. It offers hints of rivers and lakes, signs of water-altered minerals, landscapes carved by flows that no longer exist. Yet it also offers a present reality of cold radiation and desiccation. A planet that might have been hospitable becomes in our own era a reminder of how quickly environments can collapse on geological timescales. The question is not only was there life, but what happened to the conditions that could have allowed it? In that sense, each Martian day is a chapter in a larger story, the story of a world that changed. And every time Perseverance records a dust devil or a blue sunset or the quick shadow of Phobos, it's not just showing us Mars as it is. It's showing us the surface of a deeper mystery, the ghost of a planet that may once have been alive in the simplest way and is now asking us to prove it. The present-day beauty of Mars, its dust devils, its blue twilight, the hush of wind against metal can seduce you into thinking the story ends with documentation. But Perseverance is not here only to witness. It is here to prepare. In a very real way, this rover is not just exploring Mars for today's science. It is laying down infrastructure for tomorrow's understanding, and perhaps for tomorrow's footsteps. The sample tubes are the clearest symbol of that future. Each one is a sealed promise, a fragment of Jezero's ancient lakebed extracted from stone that formed when Mars was young enough to hold water. Right now, those tubes sit in a kind of suspended fate, stored, cached, waiting. And in that waiting is the power. Because a rover can detect, infer, and suggest, but a laboratory can confirm. On Earth, we can examine those samples with instruments of overwhelming sensitivity, probing isotopes, organics, mineral structures at microscopic scales, repeating tests, challenging results, arguing until consensus forms. A single, confirmed biosignature, if it exists, would not merely be a discovery. It would be a second Genesis story. It would tell us the universe did not need Earth as a singular accident. It tried life elsewhere too. And even if Mars is ultimately barren in that biological sense, the samples would still matter. They would anchor our models of planetary evolution. They would refine the timeline of Mars's climate collapse, when it lost its thicker atmosphere, when it stopped being warm enough for stable surface water. How quickly it transitioned from potential habitability into the frozen desert we see now. Mars is close enough to study in detail, but far enough that we've never held its rocks in modern hands. Bringing pieces of it home is a step into a different class of knowledge. At the same time, Perseverance has been testing the practical reality of operating on another world for years at a time. Autonomy is not a luxury on Mars, it's survival. Communication delay means the rover must think locally. It must identify safe paths, avoid hazards, execute sequences, and adapt when the world doesn't match expectations. That local intelligence is the ancestor of something larger systems that could one day support human exploration. Because humans on Mars will not be like humans on the Moon, where Earth is only a few seconds away by radio. Mars is minutes away at the speed of light. In emergencies, help cannot be immediate. The planet demands a different kind of self-reliance. Energy and temperature management are part of the rehearsal too. Day on Mars is when you work, when you move, when your instruments can see clearly. Night is when you pay the bill. The cold forces you to consume power just to remain functional. That rhythm shapes everything from how far you can drive, to how much data you can process, to how often you can risk using delicate instruments. For a human mission, these same laws will apply, not as abstract constraints but as physiological reality. Heating habitats, managing power, timing, extravehicular activity, surviving dust storms that can obscure sunlight and choke mechanical systems. Mars is not just far, it is operationally hostile. And then there is Ingenuity, the small helicopter that arrived as an experiment and became a revolution. Before Ingenuity, every rover mission was confined to what wheels could safely traverse. Slopes, sand traps, broken terrain. Mars is full of places that are visible but unreachable. Ingenuity changed the geometry. It proved that powered flight is possible in an atmosphere that is only a fraction as dense as Earth's. That is not a trivial feat. Rotor blades must spin faster, lift must be coaxed from thin air, and every gram matters. Yet Ingenuity flew, again and again, and in doing so, it opened a new strategy. Scout from above, map hazards, identify targets, and reach regions that rovers alone would approach too slowly or not at all. This is how exploration evolves. First you send eyes, then you send hands. Then you begin to send systems that can cooperate, ground and air orbit, and surface robots acting not as solitary pioneers, but as networks. Mars exploration is drifting toward that future already, one mission at a time, one technology demonstration, becoming standard practice. But the deepest future hinted at by Perseverance is not about machines. It's about meaning. Imagine what it would do to human history quietly, permanently, if one of those sealed samples contained evidence that life once existed on Mars. Not intelligent life, not ruins, just microbes ancient and extinct recorded in chemistry. That single fact would widen the universe overnight. It would say that biology is not a miracle that happened once, but a process that can occur wherever conditions hold long enough. The lonely exception would become part of a pattern. And even if the answer is no, if Mars never crossed that threshold, then we learn something equally sobering, that even with water and time, life may still be rare. That habitability is not destiny. That the universe can build oceans and still remain silent. Either way, Mars is forcing us toward the same edge, a confrontation with scale, probability, and fragility. Every day, it records every tube it seals. Every flight, Ingenuity proves possible. Is another step toward a future where the red planet is not just a distant dot, but a tested reality. And then, after all the engineering, all the patience, all the careful translations of alien light into color we can understand, you arrive at the quietest truth. Mars is not only a planet, it is a lesson in impermanence. In our imagination, planets feel eternal. They hang in space like monuments, immune to the small tragedies that define human history. But Mars tells a different story. It wears its past openly. Valleys that look like dried arteries, deltas that resemble the frozen fan of a river that never reaches the sea. A crater like Jezero is both a wound and a memory. An ancient basin that once held water, now holding only dust and the tracks of a machine. And when you watch a Martian day pass, shadows sliding across rock, sunlight bleaching the ground, the temperature rising and collapsing again, you're watching the present tense of a world that has already lived through catastrophe so slow it looks like fate, because Mars did not become barren in an instant. It was unmade by time, by the gradual loss of atmosphere, by a weakening magnetic shield, by sunlight and space weather stripping away protection molecule by molecule, by water either freezing, sinking underground, or escaping into space. The planet didn't explode. It simply changed its state quietly until the conditions that might have supported life were no longer stable. Mars is what a once habitable world can look like after billions of years of erosion, not only of rock, but of possibility. And yet the strange miracle is that we can still talk to it, not with voices, but with machines that have become our senses extended. A rover on Mars is a physical contradiction, a fragment of Earth's intention, operating on a world that never invited it. Every image Perseverance sends back must cross the vacuum, arrive as radio waves, be rebuilt into pixels, and then become inside a human mind and experience. The sunset in Jezero is not just a scattering of wavelengths through dust. It becomes a feeling, the ache of distance, the shock of familiarity, the realization that the same sun can set on landscapes we will never touch and still look beautiful enough to haunt us. And the sound wind on Mars might be the most intimate of all, because sound is touch at a distance, a vibration traveling through a medium. When you hear the Martian wind, you are receiving a direct physical message from another world. It is thin, muffled, almost reluctant, but it is real. A planet brushing against metal. A world speaking in a language too sparse for our ears, yet still crossing the void as data that becomes sensation. This is the cosmic vertigo hiding beneath the footage. Mars is close enough for us to feel it as a neighbor, but far enough that every interaction is delayed, reconstructed, mediated by physics. You are never experiencing Mars now. You are experiencing Mars as it was minutes ago or hours ago or days ago, depending on distance and transmission. You are watching another world in a constant state of temporal separation. And still, the effect is profound. Our species has reached out across space and created a conversation with a planet. But what is Mars saying back? It says that worlds change, that habitability can be temporary, that climates collapse not only in stories but in the slow mathematics of atmospheres and sunlight and time. It says that evidence matters, that the universe does not yield its secrets to hope, only to measurement. A dust devil filmed in Jezero is not just spectacle, it's a clue about heat and pressure. A blue sunset is not just beauty, it's an atmospheric signature written by particles suspended in air. A tiny sealed tube of rock is not just a souvenir, it is a fragment of planetary history, preserved for a future that may finally answer whether Mars ever hosted life at all. And it also says something about us. Because the machines on Mars are not there for Mars's sake. They are there because we cannot stop asking. Because a silent world makes the mind louder. Because we look at the emptiness between planets and feel both insignificance and obligation. Insignificance at the scale of the solar system and obligation to understand what kind of universe we inhabit. Maybe Mars never had life. Maybe it did briefly in microbes that lived and died before Earth had complex organisms. Either outcome reshapes the map of meaning. If life happened twice in one solar system, then biology may be common, and the universe may be crowded in ways we haven't yet learned to detect. If Mars was empty even when it had water, then life may be rarer than we dare to admit, and the miracle of Earth becomes sharper, more fragile, more precious. So when we say we're watching a day on Mars, we're not just consuming footage. We're witnessing a planet that once might have been a home now rendered into a desert of iron and cold. We're listening to wind that has blown for billions of years without ears to hear it. We're seeing sunsets that have repeated in silence across geological time until now, until a rover built by creatures from another world turned its cameras and microphones toward the horizon and recorded them as proof that distance is no longer the end of experience. Mars remains alien. It remains hostile. It remains far, but it is no longer unknowable. And in that transition from myth to measurement, from symbol to sound, the red planet becomes more than a destination. It becomes a reminder: the universe is vast, time is deep, worlds are mortal, and still against all odds, the human mind can reach across the dark and make a silent planet speak. Script completed.